Hello everyone, so we're back for the second part of the test review, and we're going to be looking, we've gone through the first 5 items on the test 1 checklist. So now we're going to look at number 6, Box and Whisker Plot. Don't worry about the dot plot, I'm not actually going to include that, so we're just going to do a Box and Whisker Plot. So there's 2 Box and Whisker plots. There's the basic one on the 5-number summary. So your basic Box and Whisker plot is just 5 numbers. So the minimum value, the first quartile, the median, the third quartile, and the maximum value. So if we look at a set of numbers, let's say, I don't know, maybe we have weights of football players or something like that. So let's say there's 7 of them. So 230, 235, 240, 251, 270, 280, and 305. So these are weights of some NFL players, something like that. The minimum and the maximum are pretty easy, 230, and the maximum is 305. Again, the median is just that middle number, 251. And then 251 divides the sorted data into the small 3 numbers and the large 3 numbers. That's the exclusive option. You could also choose to include 251, in which case you'd be instead looking at the first set containing 4 numbers and the second set containing 4 numbers, with 251 being shared. But in this case it's simple, because the Q1 is just going to be the median of the small data set, so 235, and Q3 is going to be the median of the large data set, which is 280. So you're just looking at these 3 numbers, and then that's your Q1, that's your Q3. And so that's all a Box and Whisker plot is you're just drawing a horizontal axis and kind of including those numbers. So let's do a scale of, say, I don't know, 10. So 230. Maybe we'll do 20. 250. Doesn't need to be super precise. 270. 290. Oops. Let me erase that. 290 is the next one. So 290 and 310. And then essentially you just mark 2 lines for your minimum value and then your maximum 305. That would be right about here. Okay, so then we connect those. So those are like the whiskers. And then the box goes from Q1 to Q3. So 235, somewhere down here, up to 280, which would be right in the middle of 270 and 290. So this is your box, and then we're just going to put a line right where the median should be, which is 251, so right there. So that's the Box and Whisker plot. It just summarizes the data. So that's kind of the basic version. Now there's a slightly more advanced version that is good for determining outliers based on the upper and lower fence. So let's take a quick look at that. So the more advanced Box and Whisker plot, rather than using the maximum and minimum, they're going to use what's called the lower fence. And then the middle part's still the same, Q1, the median, Q3, and the upper fence. Okay, so these would be our 5 numbers. And so what is the lower fence? Well, the lower fence is Q1 minus 1.5 times the inner quartile range. And the upper fence is Q3 plus 1.5 times the inner quartile range. And the inner quartile range itself just means Q3 minus Q1. So it's analogous to the range, right? The range is the max minus min, while the interquartile range is Q3 minus Q1. So if we look at some data that has like maybe some larger values, so like 10, 14, 16, 40, 51, 75, and then maybe we have one crazy big number, something like 712. Okay, these data, I mean, these are just made up numbers, but we can still compute everything the way we did before. Maybe I'll throw in one more small number in the front. So we're doing an example where we have 8 things. So let's say 5 is in there too. So in this example, we have 2 middle numbers. So our median is the average of 16 and 40. So that's going to be 56 over 2, or 28. So our median is 28. And then this data set, so when I do my list, when I cut it in 2, right, it cuts in 2 right here. So Q1 would be the average of 10 and 14, so Q1 would be 12. And then the middle 2 numbers on the big half of the list are 51 and 75. So that should come out, their average should be 63, because they're 24 apart, so add 12 to 51 and you get 63. Okay, so then we need to do the computation to figure out the upper and lower fence. So again, our IQR in this example would just be 63 minus 12, which comes out to 51. So my lower fence would be 12 minus 1.5 times 51. So what does that come out to? Oops. Sorry, just hit the wrong button there. 12 minus 1.5 times 51. So that is negative 64.5. So we don't have any. So the reason this is important, because if a number is outside the lower or upper fence, it's technically considered an outlier. That's how we determine it mathematically. So this one's going to be 63 plus 1.5 times 51. So that is 139.5. So because 712 is such a large number, that is going to be, so negative 64.5 was our lower fence, and 139.5 was our upper fence. So if you had any number that was either smaller than negative 64.5 or bigger than 139.5, it's an outlier. So therefore, 712 is an outlier. Okay, so that's how you would do the more advanced box and whisker plot with the upper and lower fence replacing the max and min. Alright, so let's go back again to the test. So we need to be able to do percentile and percentile rank. So we can actually, let's do another one, yeah. So again, this is just looking at data. So let's say we have just a bunch of numbers, 1, 5, 7, 8, 12, 23, and 45, let's say. So you could ask yourself, say, what is the percentile rank of any of these elements, actually? So let's say, what is the percentile rank of 12? So maybe part A. So the percentile rank of 12 is just, if you have your data sorted from smallest to largest, you just look at its position. So 12 is in the 5th position, right? There's 8 total elements, and it is in the 5th position. So the percentile rank here is figured out by just doing the rank of the position 5 out of the total number of values. So it would be 5 out of 8. which is 0.625. Or we could say roughly this is rounding up the 63rd percentile. So it's ranked according to that. We could also try and estimate things using this. So we could say estimate the, let's say, 38th percentile from this data. So what you would do here to figure out the percentile is we think of 0.38 as a percentage, so we do 0.38 and then we multiply it by the number of elements we have. In general that would be n, but in this case n is equal to 8, so we're going to multiply 0.38 by 8 and we get 3.04. So basically the 38th percentile so this is telling us the 38th percentile is basically in the third position of our data. So that's 7 here. So the 38th percentile is about 7. So that's what you do. Essentially this is telling you the rank of your sorted data. So to get the percentile from this data set, we take 0.38 times the 8 things, and we get 3.04. So that's roughly the third thing, so counting from the bottom up. 1 is the first, 5 is the second, and 7 is the third. So that's the 38th percentile for this set of data. Alright, so the last one is looking at Chebyshev's theorem and also the empirical rule. So I'll probably do one Chebyshev's theorem example, and then I'll have to make a third part of the video for the empirical rule. So remember what Chebyshev states. It just says for any distribution at least 1 minus 1 over k squared observations are within k standard deviations of the mean, and k has to be bigger than 1. So let's do an example. So suppose a distribution has mean 40 and let's say standard deviation 10. So we could say what percentage must be between 25 and 55. So first let's look at to figure out how far they are away from the mean. So 40 minus 25 is 15. So that would be exactly 1.5 times 10. So this is 1.5 standard deviations away from the mean. So the same is true with 55. It's 15 above 40. So in this case, k is just equal to 1.5. So 1 minus 1 over 1.5 squared comes out to about 0.556 or 55.6% of all observations have to be within 1.5 standard deviations of the mean. So I'll come back with that last part on the empirical rule.